This video is to cover problem number 2 on the Honors Test 6 test review and question 1 on the standard test 6 review. This question asks you to describe the relationship between exponential and log functions. You should be referring to your patterns of exponential and patterns of log functions review practice sheet that we did in class when we taught these lessons on both functions. I'm going to go ahead and type since it's quicker than writing by hand. So one of the things we can think about in terms of one of the 4 characteristics is we should have a good understanding of growth versus decay for each function. And so in this, I don't want you to explain why they are inverses. I want you to explain the characteristics that exist because they are inverses. So one of those might be, again, talking about how you know when it's growth or decay, but the effects of the value of b on those functions. So first we could say that exponential functions and log functions represent growth when b is greater than 1. However, if you were to look at a graph of, say, 2 to the x versus log base 2 to the x, you would find that exponential functions grow faster than log functions. So we could say that, growth, I'll just add on to this sentence and say, however, the exponential function, sorry about that, grows faster while the log function grows slower. So remember we talked about the curves, right? That it will grow rapidly if b was 2, but then it would grow slow if it was log base 2 of x. We could also talk about decay for these functions. We could say both functions represent decay when our b value is between 0 and 1. So 0 is less than b is less than 1. Let's see, if we were to type in a value for b in our calculator, so if I were you, I'd get out the calculator and type in log base 0.8 of x and then 0.8 to the x. So let me switch real quick to the Ladybug. If we were to type in, and remember we can do it a couple different ways. We can do log of x divided by log of 0.8, or we can go to math and choose log base by arrowing up and then make our base 0.8. So, oops, I'm sorry, not negative 8. So if we've got these two functions, we want to compare the rate of decay. The first one that's going to graph is the log function, and the second the exponential. So let's see what happens. So there's our log function. It actually decreases pretty fast, but that decreases pretty slow. So it actually has the opposite effect. So we could say for the same b value, the log function decays at a faster rate. So for the same b value, let's just say decays faster, and the exponential function decays slower. We also should so one of our statements out of the 4 would be exponential functions and log functions represent growth when b is greater than 1. However, the exponential functions grow faster while the log functions grow slower. So that's one characteristic. The second set of statements here is the second characteristic. So now I need to think about a third. I might want to talk about what we understand about the asymptotes of each one. So we could say that exponential functions have a horizontal asymptote at y equals 0. Oops. That should have been 0, not O. While the log function has a vertical asymptote at x equals 0. So that's a third. And we could also talk about the intercepts that we know are on the graph of each. We could say that the exponential function has a y-intercept at 0a, while the log function has a x-intercept at 1, 0. So for the exponential function, it'll cross at 0, 1 if our a value equals 1, but technically it crosses whatever value a is, while the log function will always cross at 1, 0. So that actually would answer all your, would take care of the 4 characteristics. Other things you might want to talk about are the domain. You could say that the domain of an exponential function is, think about the exponential function that goes left and right forever, so I'll put up here negative infinity to positive infinity. And the domain of the log function, remember the log function only exists to the right of 0, so the least value is 0, but it's exclusive to infinity. You could also talk about the range. The range of an exponential function is 0 to infinity. So I'd want you to show that the domain and the range are switched. While the range of a log function is negative infinity to infinity, because it goes up and down forever. So that's another set of characteristics you could mention. And that should cover it. You should be able to pick 4 of those. But if I were to consider what is an entire characteristic, this is a characteristic. So let me highlight them differently so you'll be able to differentiate. Where do I change colors? Let me just shrink it so you can see. I'll do that. Oops. Make that yellow. This is a separate characteristic. This is a third characteristic. Another characteristic. And I want this to be a separate characteristic here. Alright, so you've got 1, 2, 3, 4, 5. Choose any 4 of those that really make sense to you, or if you come up with another one, that's fine as well. But make sure you memorize those and know those, since this will be a 8-point question on your test. Thanks a lot.